All right, everyone, welcome back. And now we are going to discuss our last two variables, wind and precipitation. So starting with wind, we've all felt wind, I would think, right? You just blow on your hand. That's wind against your hand, right? Walking outside at any point, you've felt wind. And there are instruments that we use in order to measure wind. So wind direction is measured using a wind vane. And a wind vane points in the direction in which the wind is coming from, right? So in this picture in the top, there's like a little arrow here, right? And that arrow can move around, but it points into the direction that the wind is coming from. So it's kind of like, almost like as if it's a plane going directly into the wind. And when we're talking about directions of wind, like it's coming from the east or coming from the west, we add this little ly at the back of it. So winds would be, easterly winds mean that winds are coming from the east. But if we were to once again refer back to this image here, the winds here would be actually also easterly. So sometimes I always have to like draw a compass, never eat shredded wheat, right? Unfortunately, I can't draw on this for you, but never eat soggy waffles or never eat shredded wheat. So this particular example would be easterly winds. Then wind speed is measured with an anemometer. So with the examples that are given in your book, there's two. There's a cup anemometer, and it spins around, and then there's a measurement of how many rotations per second there are, and it can measure the speed from that. Or there's a little something kind of called, it looks like a propeller plane, right? And so this almost acts like both a wind vane and an anemometer. So the propeller itself can spin, and then the sort of plane can move around with the wind direction. When we looked at the images of like the weather stations that are generally put up, or like a classic weather station, there are more advanced versions of wind measurement, and those are done with a 4D sonic anemometer. So it's basically, it's really interesting. It looks like a little claw, two claws that are like pointing into each other, and it's basically shooting sonic waves and measuring the winds that way, which is pretty wild. It's really cool. And there's another really important term here that's not really discussing like wind measurement necessarily, but it's a term that we're going to use very, very often. It's called wind shear. So wind shear is the change in wind speed and or direction with height. Sorry, I'm using a different mouse, and it's very sensitive. So you can think about it this way, right? Like if you're at the surface and say you're in like downtown San Francisco or in any big city, and you're at the base of a building and you look up and you see a flag is super flopping in the wind, but at the surface you don't feel anything. So there's very little wind at the surface and a heck of a lot of wind up at the top of the building. So that would be an example of wind shear, because you're changing that direction with height. So when we discuss wind speeds, we have what's called a Beaufort wind scale. Most often, I'll try to talk about wind. Let me move my face here. I'll try to talk about wind in terms of miles per hour, but for all intents and purposes, knots are also used as well. So 1 knot is 1.15 miles per hour. So with lower wind speeds, as you can see in this table here on the right, they're pretty comparable, right? But then once you get up to these higher wind speeds, like hurricane force winds, 63 knots is kind of far away from 117, or those two numbers themselves are far away, right? 63 is pretty far away from 117. So when you have these lighter wind speeds, it's a little bit easier to kind of be like, oh, like 10 knots, or about 50, or about 20. That's kilometers per hour, but it's relatively comparable. So I want you to think to yourself for a moment the difference between sustained winds and wind gusts. So have a thinking moment. Maybe pause the video. Okay, so when we're talking about winds, we kind of have three sort of variables or vocabulary that we use. Wind gusts, which are technically driven by what we call turbulent eddies. So like these little circulations that happen in the atmosphere, and that actually brings stronger winds down to the surface. And then we had sustained winds. So sustained winds are the average speed of the wind over 1 minute. And then instantaneous winds are if you were to take a wind measurement at like that very, very instant. And an instantaneous wind could be very windy, or it could be not windy at all, right? So that's kind of a difference between wind gusts versus instantaneous wind. But consider this little graph here at the very bottom. So we have time on the x-axis and wind speed in knots on the y-axis. So you can see how much the wind varies, right? It kind of looks like this really crazy EKG sort of, like heartbeat kind of thing. So because there's so much variation all of the time, that's why we take that 1 minute average for sustained winds. And then we can see here also the maximum gust versus the minimum. And if we were to take an instantaneous reading, if we took it at exactly 30 seconds, it could be that the instantaneous wind is the maximum gust, but they don't have to be the same thing, if that makes sense. Now, another thing I want you to kind of consider is the influence of the surface on winds. Think to yourself real quick, would the winds be faster over the oceans or over the land? Oceans, land. If you said oceans in your head, you would be absolutely correct. Think about when you go to the beach. Oftentimes it can be really, really windy, like right at the water side. So there's way less stuff in the way over the oceans, and so there's way less friction over the ocean. So that allows for the winds to blow so much faster over the water than over land, which is pretty cool. So we're going to be viewing wind and pressure on maps using a really cool website called Windy, and this is what we see here. So these lines of constant pressure, these isobars, are here on this graphic. And then the wind is kind of overlaid on top of that. And then there's actually also temperature on here as well. So there's a whole lot of information here on one graphic, all on one graphic. And then we also have precipitation. So now let's move on to precipitation really quick. So we measure precipitation. It's very, very simple. We have a tipping bucket. Basically, it's like this. It's shaped in a bucket, almost kind of very similar to what this funnel rain gauge looks like. But the rain collects within a funnel, but then it drops into this very precise little bucket. And then when it tips over, then the second little bucket fills in, and then it goes the other way, another way, another way. And that's a way to pretty precisely measure precipitation amounts. And then with funnel rain gauges, there's like this, it's very much what it sounds like. The rain collects within a funnel, and there's pretty much a ruler there on one side, and you can tell the precipitation amounts through that. And then also a little side note, if you were to measure snow, right, it's very light, right? So if you were to measure snow, you literally just go out and stick a ruler into the snow and call it a day. If we wanted to visualize precipitation over a large area, instead of measuring it, but if we wanted to kind of see what's going on in a larger space, we use something called radar. So radar images show precipitation rate and area coverage. So this is a radar image here on the left-hand side over Mississippi and Alabama. And these colors here indicate basically different precipitation rates. So the kind of the warmer colors here indicate heavier precipitation. The cooler colors indicate lighter precipitation. And these things work by shooting microwave beams basically into the atmosphere. And the faster that those beams return to the instrument, the more intense or larger the precipitation, or kind of a combination thereof. But we'll talk a little bit further about radar in our next sort of lecture. And then there's other methods of data collection as well. So there's aircraft that have instrumentation on them, right? Planes need to know what's going on in the atmosphere around them, so they often collect data. We also have tons of satellites in the atmosphere. We'll talk further about that later on. And then we also have ocean buoys, which can give us atmospheric measurements while they're kind of floating along the ocean, which is pretty cool. And that's what this picture is here on the right-hand side. So just an overview of Chapter 1. That's all of Chapter 1. Holy goodness, we made it through. So these are the things that we've covered: temperature, pressure, wind, precipitation, and you should know what they are, how we measured them, and some kind of standard numbers that we talked about, especially with pressure. And then some other variables that we discussed were radiosondes or soundings, how we measure variables in the upper atmosphere, and then also weather stations a little bit, right? So what they look like, why we use them, and what they measure, etc. So thanks so much for watching this second video. Stay tuned for your other videos. Thanks for watching.